Good morning, dear all. Good morning, Swayam.
Good morning, ma'am.
So, welcome to this FDP, Swayam Ranjan, Mr. Swayam Ranjan, and thanks for accepting the invitation. Before starting the session, I would like to introduce Mr. Swayam Ranjan. Mr. Swayam Ranjan is the CEO of Analytics Valley Technologies Private Limited, Bangalore, and I'm feeling very proud that I'm feeling very proud to tell you people that he is a proud alumni of Information Technology branch Shankaracharya College. He has done his higher studies from ISB Hyderabad and Triple ITM Gwalior. He is having experience in big data analytics projects and CRM projects. He is also working as a strategy leader for the startups in the company as sales, finance, operations, new exploration space, market needs and demands, growth within our company, and revenue and profit maximization. So thank you, Mr. Swayam, and I feel proud to have you in this session.
Thanks, Ladika ma'am. It's my pleasure to being an alumni. You trusted me and invited me for the session. I'm really, really thankful to Sankaracharya College and in coordination with the alumni and taking this FDP program. I'm really, really thankful to you, and I welcome all the participants to this forum. And so I wish good morning to all of you. And please, this session is going to be highly interactive. If you wish this session to be interactive, please press 1, else press 2. I need your quick response. I'll let you know the value of it. If you want this session to be interactive, please press 1. I don't know how many of you are active. Just to press 1 or 2. I don't see any comments. Great. Bhavita Verma, thanks, ma'am. Great. So please be interactive in this session. And this is how I'll be looking forward for the thing in between. And I just want to see how interactive you are with me during the session. I'm really, really thankful to you. I'm getting good responses, but I can see 14 participants, 4 responses. The responses are pretty low, but okay for me because I have a pretty less time. And if you want it to be a blend of Hindi and English, please press 3, else press 4. If you want to see this presentation as a blend of Hindi and English both, somewhere I will be using Hindi terms. If you are comfortable, press 3, else press 4. Awesome. I think Babita ma'am is too prominent. How about others? Can you be prominent communicating with me since you want this session to be interactive? And this is how I'll make you interactive throughout the session till 11:45. Please be prominent answering to my questions. It's not like that. It's not a one-sided affair that I'll be talking and you'll be listening. But definitely, I'll be looking for certain polls out from you all over here. So I just see one response right now. So I feel everybody wants to see this training going on in English language. Am I right? Please press Y for yes. You don't want Hindi, blend of Hindi. Okay. Completed English. Awesome. Great. How about others? Why others are not participating? Great. Thank you, sir. Thank you, ma'am. Great. So you want the entire session to be in English. I'll continue this session in English. Awesome. Great. So how about others? Can you please talk to me by pressing 1, 2, 3, 4, Y and something like that? Can you participate with me so that I can see your problem? See what you are doing right now. You are trying to generate a data, right? Correct. And this data is giving me an information. What is your interest all about this session? If you don't press any data, that means it goes for a toss. You are going through a data science concept, and if you don't generate the data for me, how will I be able to do the analysis? What exactly you need from me? Correct? As yesterday's session, you have gone through like data cleansing, data generation part of it. but I don't see any data getting generated out here. Please, can you help me getting the data generated out here? Awesome. Now I can see couple of Y. How about others? Srija Nair, Kalyan Kumar. I don't see any responses from you, Mr. MS Kumar. Is there any problem pressing Y or N to it? Are you there? Kalyan Kumar Jana left the meeting. Okay, no problem. So guys, please be interactive with me. Let's make it a session where it is highly productive. So right now I'm going to share my screen with you all. And during the presentation, I'll be taking the polling like this. So please be interactive just for 1 hour, 15 minutes with me so that there should be certain takeaway from this presentation. So let me share the screen right now. Please press 1 if you are able to see my screen. Else press 2. Please press 1 if you are able to see my screen. Awesome, awesome, great. Thanks for being interactive. Thanks a lot. 1, 2, 3, 4, 5 responses. I hope everybody is able to see my screen right now. Great. So here I am going to present my screen. So today's topic is all about a visualization, but it starts with a concept of data science and business analytics, right? So let us, I hope you are pretty much aware about the data science and business analytics. I won't be able to give more time on it, but I have to quickly switch on because time is pretty limited right now for me. So let me let you know who has joined late in this presentation. I am a CEO of Analytics Valley, Bangalore, proud alumni of Sri Sankaracharya College of Engineering and Technologies, and pass out a pioneer batch from Information Technology branch. So these are my details. Feel free to get in touch with me through LinkedIn, through my Twitter, through my phone. This is my direct mobile number. You can get in touch with me directly and through my email ID. Okay, so if you want to take a note of it, I'll give a 30 seconds pause out here. So anything which makes you comfortable, you can take a note of it. So now coming to the approach of data science and business analytics, we are going to talk about. Let's understand, like you might see, I don't know the blend of the audiences out here, but let me take the concept of software engineering, where we talk about a SDLC life cycle. So software development life cycle. So similarly, we have an analytics development life cycle, how it goes basically. So analytics always start with a business objective. There is a problem statement which you might have heard from Avinash yesterday. So just taking a brief recap of what you have done yesterday and moving it on to the visualization part of it. So business objective, first you define your business problem, then you make your data ready, then you talk about a data preparation which you have seen yesterday, right? Then you try to, based on the problem statement, you try to do an analysis that which is the best fit model which is going to work on the predictive modeling part of it or artificial intelligence part of it. So you have to understand what is models all about, how do you fit it into a any business objective, which comes through multiple exercises which which will be going through after the session. Then comes the evaluation. When you talk about a predictive analytics, then we try to understand whether the model is a best fit model or not. How do we define the best fit model? The best fit model comes with a prediction value, like this is 97% accurate, this is 96% accurate. Now how the data talks about the accuracy of any problem statement. What happens is, like, you generate a data as you have gone through. I'm just giving a recap right now. That first we try to there is a test data and there is a trained data, right? So we try to train the data, and with certain samples we try to test the data, and we try to identify the level of accuracy out of it. That is how you understand that what is the level of percentage you are getting an output based on different models that you apply to a particular problem statement. Right? And then finally, what you do is you come with a visualization perspective. Okay, this is how the output should look like. Whether it can be a form of an image part of it, it can be a form of a graphical part of it. The visualization can be in any format. Okay, So moving on to the second, so there are many frequently word jargons that are being used, and I hope you should be pretty much aware when we talk about data science, when we say analytics, when we say business analytics, when we say data analytics, there are specific term, value of the terms that we use during our communication, because once you speak one word, it makes a lot of sense, right? So if I ask one question from you all, what is data science? Is anybody can let me know quickly by buzzing in the group what is data science? A small definition. Or you can unmute yourself and quickly speak to me. Since we have been going through this session from yesterday itself, so I just have one quick question. Let's make it interactive, right? Because one side affair doesn't work. It should be a both side affair, right? So I want you to be equally interacting with me quickly. If you don't want to speak, please say no. Press N for no. I'm perfectly fine with that. I'll move on. If you want to speak, please press yes and speak to me. I don't have a time, I have a very limited time. Yeah, field of study that combines domain expertise, programming skill, knowledge, mathematics. Awesome. Awesome, awesome. I'm really thankful to you, Babita ma'am. You came out with the best definition of this method, technology, and science that generate insight from data. Awesome. So this is partially correct. Avinash sir. Okay, anybody else who would like to speak, want to portray his vision? So Babita ma'am is really nearby what exactly the data science is all about. Okay, so let me share my screen quickly to make you understand what is data science and other terms you can go through once you have this presentation with you. Okay, so let me know if you are able to see my screen. Are you able to see my screen? Press one for if you are able to see my screen. So let me quickly explain you this particular term, right? So now we are sitting on the version 4 model right now. Version 3. Version 3 model of data science. This is, sorry, the diagram may not come up that good, but yeah, I'll try to cover up as much as I can for you. Perfect. Okay, so as let me say quickly, you need subject matter expert, you need to know computer science, CS, you need to know mathematics, and you need to know statistics. And if you see here, this particular portion which you are going to see in red color right now here, overlapping of the entire 4 is called the data scientist. Okay, now this is called V3 model. This is basically a V3 model of data science. This is V3 model of data science. Okay, I hope this concepts make you clear what is the concept of data science. So if you should be, now every industry, when I talk about a subject matter expert can be from healthcare industry, can be from retail industry, it can be from any industry, airlines industry, high tech industry, anything it can be. So those people who have a subject matter expertise in the particular field, they are called subject matter experts. Now if you have a coding experience like Python, you work on Hadoop, you work on multiple technology which are used for data science and big data technologies. Okay, on top of it, if you are really expert in mathematics and statistics, right, that gives a real flavor of your data science. Initially in V2 model, mathematics and statistics was combined. Okay, it was under one Venn diagram. But with V3 model, they thought, they came with the concept that mathematics is a separate entity where you should be very thorough with, and statistics is different thing, like sampling, sampling and probability factors comes under statistics, and mathematics, when you talk about a Fourier analysis and other things when you do for image processing, all these concepts are required, and together it gives you a complete gamut of a data science. I hope you all agree with me. If you all agree with me, please press one quickly. Awesome, great. If you agree with me, please press 1. So I have given you a brief intro about this. So likewise, I'll be giving you slide input to this particular objective. And I want you all to make sure that your other things are being covered by you. If anything is left out, please let me know, offline queries. I can take it up. And I can revert back to you. Really, thanks for the understanding. So coming back to business analytics, data analytics, predictive modeling, which you already, Vinas has talked to you about this yesterday. What is regression? What is machine learning? What is clustering? What is supervised? These are all the concepts which are being, terms are being used. And if you really understand what this means all about, it's pretty easy to take ahead any data science project, within your course curriculum or as a part of your professional career. Now, the exploratory data analysis is something which you take part as a part of a visualization. Suppose what happens is you get a data, but you don't know how to react on the data. So what you do is you take an approach of exploratory data analysis. I'll give you a quick example of exploratory data analysis. What happens is, suppose somebody comes to Bangalore, like Babita ma'am comes to Bangalore and she's not aware about a Bangalore, right? So what will happen is he will ask Sswayam, hey Sswayam, I have to go to, my friend's house. Can you lend me to some malls over here? And what I do is I take Babita ma'am to the mall and I drop her over there, and she goes inside. Now mall is pretty big. There are different sections. Now what needs to be purchased, she has to decide. So how the mind is articulating is, like right now I have to go and I have to purchase a fruit for him. So what he will do is, inside the mall she will look for a fruit shop. Fair enough. She enters it. Now she is getting directly into the problem, solution to the problem. Like, where exactly can I get a fruit? Right? So she looks for a shop first within that particular mall. So now the wider scope becomes a smaller. That is how, what happens is, when you get a problem statement and you get a huge amount of data, first you try to understand what data you have to act upon. Right? So this is exactly what Babita ma'am is trying to do here. I'm just correlating with a real-time example right now. Now, once he enters the fruit shop, now there are multiple varieties of fruits. Now, which fruits he has to pick it up? Now she decides I have to go for an apple. Right? Now she looks where exactly is the apple stall is all about. She reaches the apple stall. Now see, there is a red apple, there is a green apple, there is a yellow apple. Now she is able to see there is a small apple, there is a big apple. Now which apple she is going to purchase? Now we are trying to understand where exactly is the problem. Right? Now she is penetrating in and she is coming to the definition of a problem by looking at the data. So what she's trying to do is, she's trying to explore the data in a big way and trying to achieve, like, okay, if I pick this data, this particular problem can be solved. Okay, this is what it is all about, the concept of exploratory data analysis. So whenever I request you, whenever you get a data, don't get panic. Okay, understand the problem, try to get a deep dive into the data and try to retrieve the information out of it. And if once, like the approach what ma'am adopted for just buying an apple, so now you have sales data. Sales data is like a customer data, there is a order data, there is a quotation data. Sorry, there are multiple sort of data which is being presented to you. So this is how you have to make sure that you have to take the customer data, you have to take the dimensions accordingly, then you have to take the order data, you have to take the dimensions accordingly to solve the problem statement. Now, if you all agree with me, can you press 1? And I hope you have understood exploratory data analysis in a quick way. Can you press 1 for this if you have understood, or if you have any questions, please press 2. Awesome. Great. Awesome. Thanks for your responses. Great going. Okay, now probability, this is a concept of statistics which I've already talked about. So there is a probability factor. So what happens is, this data science concept is not like giving an exact figure, but we works on the probability because it's a prediction. I'll tell you in a simple layman term, like, you go to a pundit, he looks at your hand and try to project something about whether your marriage will get happen or you have any problem, where it is going to be get solved and all those things. So here also what you do is, you are a pandit of data here. When you have the data with you, you become a pandit of the data and you look at the business problem and you try to solve it out. Okay, so here also we are doing a prediction, a probability out of it. We are not giving a 100% result, but we say, because there is always a missing data whenever you work on the data, accuracy level is never 100%. Because why there is not a 100% accuracy? So can somebody tell me, like, why this probability comes into picture, and we say that whenever we work on a data, that data is never 100% data. Can somebody tell me about this? If you have understood by question, press 1, else 2. Because I may be pretty fast out here. You don't understand my question. Great. So what I was asking is like, let me put it in this way. Uh, 1 second. Data, right? Now, when we say, like, you go to multiple segments, I will say, like, you go to multiple hospitals, right? So, multiple hospitals scatters your multiple data. Like, somebody, you go to a hospital A and they take your first name, last name, email ID, phone number. And when you go to hospital B, they take your first name, last name, email ID, phone number, gender, date of birth. So they are acquiring more data. So there is no standardization of data as such with respect to any vertical that you talk about. So what we say here is that since the data capturing itself is not standard across any of the verticals or domains, airline industry you talk about, or hospital industry you talk about, any industry, there is no standard capturing of data. That's why whenever we do any predictions, the probability is not 100%. There is always a gap factor. A risk is associated, right? This was my basic question which I was looking from you, like there is no standardization of data, so this probability always comes into picture, right? So coming back to our PPT, that is how the probability works basically, because we try to work on the level of approximation rather than giving a direct response to it, whether it is 100% or 200%. Right. So I think this is a very pretty common jargons which you might have heard about: velocity, variety, variety and volume. So I hope this term is pretty much well known to you. I'll not get deep dive into it because the term itself, is self-explanatory. When you talk about a volume, it has to be volume of data. When we talk about a volume of data, then it has to be in terabytes, zettabytes, petabytes, right, and yottabytes. So that is the volume of data when you work on a big data technology. So velocity, when you talk about a velocity, data are getting, getting generated per second. A huge amount of data are getting generated. I'll make you realize a picture of that. What is the velocity of a data? Variety means there is no consistency of the data, right? When you talk about, like, somebody gives a smiley, somebody gives a text, so the formats for the communication are becoming pretty different. And veracity. So when you talk about the veracity of the data, so when, like, initially, if you have seen, like, when you used to chat on WhatsApp, what used to happen is, for what response we are trying to give, like, the statement is two statements back, but we are trying to give a response to that in third and fourth line. So what is happening is it is creating ambiguity among the data, among the communication. So all these things are the data which are basically ambiguous data, basically, which doesn't make any sense the way you want to present or communicate the data, and this happens in day-to-day life. So all this constitutes, so these are the major factors which constitutes of a big data technology. Now coming to the concept of harnessing big data objective, how it came into picture basically, right? So if you go back long back story, to the year 1968, there we used to see that we have an operational data set, right? Means for customer data we used to capture in multiple tables. There was no relationship, there was no RDBMS concept there, right? Individuals data was, and the data was being replicated in a big way, right? So the KB size was pretty high, storing the data and other things we developed. We came into when we moved on, then those problems were getting resolved through RDBMS, right? Okay, so relational database, to the certain extent, primary key, foreign key, resolve multiple problems of ours, solve the multiple problem by by building the relationship. Now, with Invent further, we came to the analytics part of it. Now, what I'm trying to tell you here is that initially we have a concept of OLTP, means we were capturing only the transactional data, not the analytical data. Analytical data was, being done on pen, paper, something like that. They were looking at the data, they were counting the data, they were getting information, and they were manually plotting it out. So now that this particular reporting part is called the OLAP, online analytical processing. Now what happened is, like, the data warehouse came into picture because the transaction data was being stored at one place. Now they developed a warehouse part of it so that they can generate a report on top of it. Okay. And then with the advent of technology and the era we are sitting here right now, everything is happening in real time. When we, it's you may call it a real time, or it may call it nearby real time, not exactly the same time. Okay. So what is happening here is we are pushing the data and we are getting the analytical part on the same time. Like if I open my system today by 10 a.m., I'm able to see I'm having 10 customers right now, with the worth value of 2 million. But as soon as I open by 12 o'clock, I can see I have 15 customers and the worth value of $4 million. I'm catering to it. So this everything is happening in a real time when I open my dashboard. This is called the real time analytical processing. So please let me know. Please press one if you have understood the concept of OLTP, OLAP, and real time analytical processing. Please press one for it. Awesome. Thanks for being so attentive. Really great going, but few I don't receive a response. Are you really with me? If not, please press two. Are you all really with me? Because I hardly see responses. Still, I was expecting that with the advent of the session, I'll be receiving more responses, but sorry, I'm not able to see more responses. Great. Uh, Chandraha Sahu sir, thank you for your response. Anybody would like to give a quick response? Are you able to understand my point? Please press one, else press two. Quickly, this response I need it from everyone. 23 participants, excluding 4. Everybody needs to respond it back to me. Are you able to get what I want to say? Because these are the very vital concepts which I am giving it to you in terms of data science. Please press 1 if you are with me. Please press 2 if you are not with me. Because I have to be fast. I'm helpless here because a lot of portion needs to be covered in terms of concepts so that you are able to grab almost everything in terms of data science and visualization by having basics out of it. Please press 1 guys if you are with me. Hello. Are you able to understand my question? Please press 1 if you are able to understand my question. If not, press 2. I'm not getting any responses from anyone. Please be interactive. Please be interactive. Anyway, I'll move on. So just try to understand. Now I'm coming to business intelligence part of it, which is called the visualization. Now let's understand the story, how it got initiated and where we are sitting right now. So initially in 90s, if you see, there was a standard reporting used to happen, which was a fixed reporting. Then it came with the ad hoc reporting that if required, I can generate a couple of more reports. Then the concept of drill down happens. If I want to see the details of that particular report, I can drill down with a particular concept, and alerts started coming in. Alerts means basically like if anybody is going above the KPI or below the KPI, the alerts would get generated on top of it based on the reporting. Now with 2000, if you see, this statistics was more prominent. Okay. Now what you have seen till the alerts, those are called basic analytics, covered as a part of a descriptive analytics. Okay. Then came the predictive, and then came the prescriptive analytics. So right now we are sitting in the era of predictive analytics, where we are mostly doing a statistical analysis, forecasting analytics, predictive modeling, and other things. We are sitting into that era. Though we have came to a bit of an optimization to cover the prescriptive analytics part of it, but yeah, almost the research are going mostly on the optimization part of it and building multiple models and stochastic model, where we are trying to do a behavior analytics, like when I'm happy, when I'm sad, when I'm giving any response to a particular query, what mindset I am in. Because what happens is the humans are pretty much fickle nature. If you are very happy, you will give a very good feedback. If you are not happy, the responses go for a toss, the feedback go for a toss. Like like after the session, if you are willing to give my feedback, if somebody is really happy, something good news they have heard, they will definitely give me a very good feedback. And if something has gone wrong, definitely I'll be getting a very bad feedback. So that feedback basically, when you are new, because that also happens based on the momentarily action that you are sitting into. So those sort of research are going on, so that the normalization of behavior analytics can be done in a big way. When you are happy, you should be able to hear love songs. When you are sad, you should be able to hear a sad song. These are all the behavior analytics that is going is coming up in a big way in terms of the research and R&D area, which is happening right now in a big way. So it is just an insight to you. This is just a story about like how we have we have came up with the inventor of data. When you see on the left hand side from megabytes to petabytes, we are sitting on a petabytes, zettabytes data right now. It's going up, and you are sitting on a yottabytes of data right now. Okay, so now if you see here, there was initially a small ERP system. Now what happened is, in the ERP system, we used to fill up the CAP form. We used to manually enter the data, right? Now what happened is, now there were a lot of errors that was getting created because of that. So now what happens is, with invent of internet, we ask the customer to fill up their own individual informations, right? So now we started filling up the information. We started getting registered with an invent of internet. But what happened is, there also a lot of garbage data started getting created. Lot of bots which was created, which was filling up the data automatically, and a lot of junk data were also getting created. So with this, there were a lot of so with invent of technology, parallelly the technology that was also getting created was for the disruption also, as well as for the goodwill also. Fair enough. Now, since lot of data, we were sitting on a terabytes and petabytes of data, but now all junk data has to be removed, and we have to come out with the correct data. With that, what happened is, we came with a concept of big data, where we can do an analysis of a customer and other things. We can filter out the junk data, and we can come out with the right data to make our observation, to come out with an observation in a big way. So what you have seen is, like yesterday, you might have seen the data are getting generated, and we are cleansing the data. So why the cleansing of data came into picture? Because of all those junk data. Though we have a system, but people tend to generate a lot of junk data, and we are filtering it out and making a correct data to do an observation on top of it. So I hope you are getting the concept why the cleansing is required in a big way. In a big way, even though we are generating data with our own. But understand that there is a parallel competitor sitting as a bot, which is generating a lot of incorrect data for you, and it is just filling up your database in a big way. Okay. Now let's understand the velocity of a data per minute. Now you can see there are so many social media, there are so many apps, are there floating in the market right now. Correct. So you can just observe the person who are watching a YouTube right now. Okay, the people who are sending emails right now at a point in time. So I'll give you an example right now. So just for a minute, I would like all the participants to close your eyes. Okay, now just think of one app that is called WhatsApp. Okay, just think right now, you are sitting at a home, everybody is sitting individual at a home, somebody or the other might be using a WhatsApp right now. Okay, so just imagine within your family members, if somebody is just chatting right now, sending an email or sending a video or sending a voice message, they are generating a data. So that particular volume of data is generating right now at your home. Now from your home, just try to visualize, just broaden your area and come to your society. How many people might be using that? Okay, at per second, forget about other social media, just think about WhatsApp. Okay, now come to your level of district level. Okay, just say Bhilai. Okay, within Bhilai Durg, how many people right now at this point in time when we are talking to each other, how many people might be using a WhatsApp? Come to the Chhattisgarh level, how many people are using the WhatsApp right now? Can you see the per second data getting generated? Can you observe? Now come to the India level right now. See the volume of intensity of data that is getting generated at this point in time. So the people who has visualized this, please press 1. The people who didn't visualize this, please press 2 right now. Awesome, great. So you are able to see the volume of data getting generated. Awesome, really thanks. I'm getting a response right now. Awesome, good going. So now this is where we are sitting in the era of big data, the volume of data. So we just talked about right now a individual person as such. You talk about a business unit, you talk about a manufacturing unit, you talk about a healthcare unit. So at a time, business plus consumers is generating so much amount of data where the data has to go. Somebody has to intervene and has to create and has to come out with a proper responses to it, whether it is right or wrong. right? That is where we say right now, point in time. I'll just share my screen. Let me know if you are able to see my pen brush. I'll just show you one figure here. If you see here right now, uh, the data growth is happening exponentially, right? It is e to the power x. But the data scientists, a real data scientists in the market, are linear, right? We are not able to achieve the the requirement of a data scientist so that they can fulfill the need of the market, because with time, if I say this is a time graph, okay, and if I say this is a data generation graph, okay, with time the gap is increasing, demand and supply. See, now if you talk about every vertical, every domain out here, there is so much requirement of a data scientist out here, but people doesn't understand what exactly is data science, what is modeling, what is predictive modeling, what sort of analysis we need to do. So my request is, like, if more you work on the problem statement, there are multiple problems sitting on Kaggle and all those things where you can get lot many data. You start working on it. Trust me, any of the students who wants to join the session, your students, definitely the market is open. And I have taken multiple interviews, and sorry to say, I was not able to qualify the candidates because they say they are data scientists, but the first question is they don't know what is data science. Simply having a understanding of R, Python technology doesn't mean you know data science. Okay, because if within Python, if you know Python, Python has a two ways. Python can solve a multi-threading concept, and Python can also solve a machine learning concept. Right? So we need to understand where is your skill set lie about. Okay, so people who are learning R, Python, any language they learn. Just give me a second, please. So anybody who's learning R, Python, or any in terms of visualization tool or something, they call themselves a data scientist. That is absolutely wrong. Okay, so they need to understand on which area they are working upon and what is the objective. Now, can you see here? I have just given a very crux of it. You can see here execution models and data types. Right now, if you have a streaming data, right? If you have a streaming data, you can see all the figures. The red color one, it is mapping with batch execution. You can see the green color one. You can map it with learning analytics. You can see here yellow color part of it. You can map it with supervised online learning or offline learning. You can see the color coding out of it over here, which comes to online learning. So this is what is the concept of streaming data. These many are getting mapped to it. Okay, when I talk about the supervised learning, you just look at the below. It consists of only two to three colors. Red color, so it covers up like serial execution, parallel execution, streaming execution, batch execution. This is a complete summary of the analytics, the way you have to do. When you are trying to work on supervised learning, you can do serial execution, you can do parallel execution, you can do streaming, you can do batch execution, you can do anything. And when you come as a part of learning concept, so you can do online learning as well as offline learning, right? When you see the predictive analytics, right? Predictive analytics consists of a structured data here. Okay, it consists of a supervised learning. It consists of unsupervised learning. So when you talk about, when you look at the graph in a deep way, you can have your own block diagrams ready. Like if I have to do predictive modeling, then I can do on a structured data, I can do supervised learning, I can do unsupervised learning, you can do anything. And this graph, though it looks clumsy, but it has a very crystal clear figure if you look in detail, like how the the executions are being maintained in terms of analytics part of it, whether you say business analytics or you say data analytics part of it. Okay, so let me list the theory of the technologies that is getting involved here. So there are multiple things. So fundamentals we already talked about. So data mugging, so which was discussed with you by Avinash yesterday. Data ingestion already discussed. So I'm here to talk about a visualization part of it, a sample visualization. What is the best practices of visualization, so that it helps you once you develop those visualization, you are pretty much aware about the concept of, like, this is, if I do this way, somebody should be able to make inferences out of it. Okay, that is what we are going to discuss. This is a simple graphical diagram. If anybody know data mathematics segmentation, that was the initial. I have discussed this with you in a couple of previous slides about the descriptive, predictive, and prescriptive analytics. If you see here, this is what I discussed about. You see a descriptive, predictive, and prescriptive analytics. So this is in the form of your presentation where you see when a statistical modeling came into picture, that was called a predictive analytics. When real-time data came into picture, that was actionable data, and it was a feedback system. You can see here. This is called prescriptive analytics, which talks to a stochastic, optimization, which talks about a behavioral analytics. So all these things, if you start looking at the data set, and you will be able to correlate the previous one, so that this is a format which is in terms of like visualization format, like a very small summary of it, what you have seen the details initially. Okay, now let's come to the visualization part, the topic of today, which I want to discuss with you. Now you see here, like there are green color, light green color, yellow color, red color, multiple color. I have just taken the generic graph right now. But if you see here, there is something unique in this particular graph right now, in this red color, which has gone exponentially. I'm sorry, which has gone way out ahead because of, might be at this, it looks like there is certain data issue out here. So when you do your exploratory data analysis, or when you try to analyze the data, right, this is what you find, like there are unusual behavior of the data. When you do a blocks plotting or something like that, you are able to identify that some data doesn't fit into this technology. I'll give you a brief example, a small example. Me as a CEO of a company, and this Ambani is Mukesh Ambani being one of the CEO of the company. Though we both are the CEO of a company, but what we get as a remuneration from a company itself, okay, are entirely different. So I cannot map Mukesh Ambani's salary being me CEO of my own company, a salary, right? Because our takeaway is different. So when we do a structure, when we do a clustering of a data, that Mukesh Ambani becomes an outlier from the certain set of a group of a CEO who are retrieving the information, because we are a startup, they are a well-established company. Okay, that is how it is happening right now. I hope you are able to get my information, that how the data analysis helps you to identify the outliers and the unique data out of it. If you are with me, please press 1. If you are not with me, please press 2. And if you have any queries, please press 3. Awesome, 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 awesome. I think most of the people are with me right now. They are sincerely hailing me. Really thanks to each one of you being so participative. I'm really, really thankful to you. Great. It's giving me interest too. Let's move on to another. There is something, a presentation called a visualization called a word cloud. I hope most of you are aware about the word cloud. So can somebody let me know what is the significance of the word cloud? Anything quickly? Achha, first thing, have you heard about word cloud? Number, press 2. If you haven't heard about the word cloud, press 3. There is no harm. If press 3, awesome, great, awesome, awesome. Nobody has heard about a word cloud, awesome. Now I'll give you the significance. It gives me an interest to give you, yeah, Babita ma'am, you have to be very interactive. When I say if you know, you have to press 2, else you have to press 3. I may change my icons, the numbers at any point in time. So please be interactive. So it should be number 2, not 1. Thank you. So word cloud is basically, I'll give you an example here. Let me, word frequency that gives greater prominence of words, more active. Awesome, great, 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 great. Awesome. See, I have taken one from news from Stanford University. What I do is I don't have a time to read what is written out there. Okay, but I'm a pretty expert in my area, what I know. Suppose I'm a good doctor and I need to know what is written. So if I read line by line, it will take a lot of time for me, right? And so I just, as a doctor, what I do is I just copy this statement from here to here, right? And I go to a word cloud. I'll share this link with you. I just copy over here and I say generate. Now, if I see here, it talks about an organization, the bigger pictures, as ma'am said, right? They're talking about a life here. They're talking about an organization here. They're talking about a management here. They're talking about something called a Stanford over here. So now the person who is really good to to understand these terms, they will quickly retrieve the information what this chapter is all about. Okay, now these are the mota terms, are big terms which you can, once they correlate, you are able to correlate the entire story. Okay, this particular paragraph talks about this. So this can only be done who are the subject matter expert, not by anyone. Okay, so I hope you got my point. If you are with me, please press 1, else press 2. Where am I? Okay. Yes, please. Awesome. You got, so I hope you understood the concept of word cloud pretty quickly. Thank you. Awesome. Great going. So likewise, as you have seen now, now these are the multiple ways to represent, right? Now, when I talk about geo, it's, you pretty well know I'm talking about India, Australia, China, Europe, which country. And I just want to see, like I will say, these are the list of corona patients in multiple geographies. So what I am trying to do here is I just taken a graph, a location graph, and I have just identified these corona patient and non-corona patients on the screen right now, which is pointing to a particular geolocation. So, one second. Actually, I'm near airport, so a lot of helicopters and aircrafts keep flying from here. So I'm extremely sorry for it. So now, if you see here, like this may be a a Durg location. Under Durg location, we are trying to identify, like this is a location basically, and under this location where are the corona patient. So we are able to position it. Now, if you talk about a business term, in terms of business term, you see like Europe, like from where the most of the onions are getting exported to India. Like there are multiple countries who are exporting, producing onions, but from where we are exporting it back to India, or India is importing to multiple countries. So by looking at this geospatial graph, you will come to know quickly that, okay, these are the countries where we are exporting to. So the people who are really working on the visualization has to be very sharp, whether I have to present a bar graph, pie chart, geolocation graph, or how I can present it, so that the person who is looking at the graph should be able to make certain quick inferences out of it. So what exactly that visualization gives you a concept that you should be able to retrieve information as soon as possible without wasting a time. Because if you are going for a meeting and you have to derive any inferences on the fly itself, then you can look at the graph, you frame out your storyline based on the observation of the real-time dashboard, and you are able to present it. Graph, which is another way to present the data. Like this is about a time series analysis. Okay, suppose January, February, when you see these are the months are basically the time series analysis. Now when you talk about the price changing, they are talking about like when it goes pretty high, when it goes pretty low. Now if you are able to do the analysis, like somebody is very good at purchasing the gold, right? And if you see the old past history data of the gold, how it has been increasing, when it comes high, when it comes low, then trust me, you will be able to make maximum profit out of it. If the person who are really good at getting engaged themselves in buying and purchasing of what do you say, that we generally do a stock market basically. Now you have to be very sharp analyzing the data. Now you're sitting on, now few minutes back you have visualized the enormous amount of data that are getting generated. Now you have to stick to a particular segment. You have to be expert into that. You have to analyze the data so that you are able to make a maximum benefit out of it. That is what this data analysis is all about. I hope you are getting the observation what I want to say. Okay, in a very layman terms as much as I can, and try to fit into your shoes so that the best example I can come out with. Now you just see, like you see the size of data from gigabytes to zettabytes. Now you're sitting in yottabytes. So this is a further extension you can give it to it. Okay, now this is just an understanding that where there is a big data, there is big data analytics comes into picture. But what happens is when you talk, when you go to a company, they have a huge amount of data, but they're still sitting on the traditional analytics. They are still doing simple BI. They are not able to retrieve the correct data out of it, and they are not able to do correct, and they are not able to retrieve a perfect analysis out of it, because they are working on the many of the junk data which is sitting in the database. So cleansing is one of the very important topic when you intervene into a data science perspective and you try to analyze the data in a big way. And some companies, I was working with Ricardo Powell, who is a cricketer in the Caribbean. Her wife name is I missed her wife name. She's running a business. They have a very small data, but he was very curious about that. He wants to do machine learning and all those things. When we saw his data, it was hardly in KBs. Okay, and we said that sorry, Ricardo, we won't be able to do the advanced analytics of predictive model what you're looking at because your data is not high. So we help them first to generate the data so that he at least they come to the terabyte of it, a gigabyte of it, so that we can start doing something for him. But if you really see that till terabytes also the data are considered to be a small set of data, right? It's not a huge amount of data, right? Anything beyond petabytes, zettabytes, and yottabytes are considered to be a volume of data, a big data solution where it basically comes into picture, right? Okay. Otherwise, you can do with a small data set just for practicing. Definitely, you can take the small data set and you can work on predictive modeling and other things, which will help you out in a big way. Now you have heard about a term called structured data, semi-structured and unstructured. What this data is all about. So any RDBMS or DBMS, what you see are the structured data because it has a proper definition of by a metadata, right? Semi-structured data, when you create XML file, JSON file and all those things, they are considered to be a semi-structured data. Okay. Now any communication that you do as a part of your Facebook chat or a WhatsApp chat or something like that, those are basically considered to be unstructured data where you put a smiley text and all those things, or you float a video for anything, or you right now there is a concept of Giphy also where you put a GIF icons and other things. These are all called unstructured data, and this is where we are analyzing the data that we are trying to sense the through those emotions, through those texts, we are trying to understand that is it really a happy news? Is it really a sad news? Is it an emotional news? What exactly the information is all floating about? Okay. Now let's understand. I'll skip this one right now. Okay. Because let's come to the objective of data science because I have very limited time left out. But yeah, this definitely this because this is all a story about how the business works in terms of data science. So this is just an input for you all. I wanted to show you a video also in terms of data generation. Okay, now let's quickly come to the concept of better visualization, right? So there is something called quantitative, discrete, continuous, categorical. So these are data which you have already covered it up in the study session. I just quickly have a recap. Quantitative means something like which can be measured 1, 2, 3, 4. Qualitative means good, bad. There is no measures to it. Okay, but if anything you want to make it quantitative, you have to say good is 1, very good is 2, something is like that, so that you can analyze the data in a better way. Because you will not be able to analyze anything which is good or bad or it's very good. There is no range of it. But yes, definitely once you say anything lies between 1 to 2 is good, 2 to 3 is very good. So if anybody who is interested giving 1.2 number, 1.3 number, we are able to analyze that this is the category it is lying up to. Discrete means you understand the Boolean terms 0 and 1, right? So that is discrete. So continuous data like continuous data, you can say something the time series analysis, right? So the data that my sales data is cropping in continuously. So every day my data, every month my sales data comes in. So that is called a continuous data for me, right? Categorical data is something like the type means you define a category. Like I sell, something called food products. I sell something called cosmetic products. So we are building a categories of it, and we are trying to see what is the sales volume of each and every category, the data which I am selling, and which is giving me the best result out of it. Okay, so you can see here categorical and quantitative analysis right now. See, this is Q1, Q2. So you can see like here, these are all basically. Can you tell me this is a quantitative or qualitative data? Can you just if you feel it is quantitative, press 1. If you feel it is qualitative, press 2. Is it quantitative or qualitative? Just look at the data. It is quantitative or qualitative? Awesome, great, yeah. It is quantitative data. Now you can see here category, right? Quarter one, quarter two, quarter three. Initial example, I gave you a cosmetic product, a grocery product, and all those things. You are making different categories out of it. That is how you do a proper analysis of the data. Now there are multiple things that there is a nominal comparison, there is a ranking, there is a part to whole concept, deviation, right? So this is the when you take a visualization concept into picture, first you need to understand what exactly I'm going to do, right? So now if you see here nominal comparison is something like you just put the data based on the category, right? Third one is the highest, second is the lowest, it doesn't matter, but you are just presenting the data in a nominal comparison so that I can just look at the bar graph and I can make inferences out of it. Oh, my this portion is really doing good, right? Now if I have to do the ranking first, second, third, fourth, and fifth, like we generally do based on the marks, right? So this is first, this is second, this is third. So we try to rank it. So yes, definitely. So who receives the first mark? So now, right now, I want to compare the top five. So you can just take, make off a top five, and you can compare what is the marks difference between the top five. Okay. Now, when I talk about a part to whole, that means like I have multiple subjects, right? English, math, science, social science, history. What I do is I try to make out of 100. So everybody, what they do is they just simply draw a pie chart, but the pie chart concept is entirely different. You can't simply draw a pie chart just because you need a pie chart. When I draw a pie chart, am I able to make inferences out of it? Because if you see, there are a lot of small lines that comes into picture. Is it a best visualization? It is never a best visualization. You have to put that into a category, and then you have to, when you are doing, pie chart, maximum you have to put 5 or 6, categories into picture so that your pie chart becomes really good, or a donut chart becomes really good. Right? You can't put 10 elements within a pie chart and you try to present it to someone, which presentation is there, but inference is not there. So whenever you are doing it, you have to first see, am I able to make any inferences out of it? First, you have to observe, and then you have to present it to anyone. Okay, so this is what is called a part to whole concept. Like in English, there is a 35% of the student who has passed the exam. So out of 100%, I'm making 35%. This is called, and together the pie chart should constitute a 100% objective. If it doesn't, there is no value of a pie chart. Trust me. Because we need to know, because it is just not simply a presentation, but making, when I stand and when I look at the particular graph, I should instantly be able to make a inferences. So there are so many wrong graphical presentations are being done in the market right now, because the people doesn't have any understanding what are the best practices. Okay, now when you talk a deviation about it, like it can be considered as a time limit graph. You can take the differences, you can take the running measures, and you can see what is the deviation that is coming out. Okay, time series analysis, what I have already talked about, it may be based on the time 10, 12, 14, 16, or it may be in the months, whatsoever you see as it is a time-based objective, that is called a time-based graph. Okay, now let me quickly present it to you. I hope you must have gone through yesterday this linear regression plotting, basically how the relationship between the two are built, right? So initially we have seen that we draw the dotted lines, but right now the data is so high that when you see, we try to come out with a best fit line. So you see here a straight line in between, which is a best fit line, and you see the data are revolving around. So when you draw a perpendicular line on top of it, that is called the error of margin. So these are the errors which is happening, and you are trying to find the best fit model out of it based on the regression analysis, which Avinash might have covered yesterday on this particular objective. So now you see a bar chart. So basically, if you see, the bar chart can be presented as a vertical as well as it can be presented as a horizontal. Now, when you try to analyze, when you talk to someone and you see that you want to do a comparison, just put them 2D graph. Never ever go to 3D graph, because 3D graphs has a lot of illusions. 3D graph never gives you, it looks beautiful, no doubt about it, but it gives you a lot of wrong information. Okay, now coming back to the stack chart, this is one of the chart that is being presented out here. Now if you do a stack chart, like suppose if you see on the first graph itself, right, it is being stacked, right? There is an email, there is an organic search, there is a paid search. But if you see, if it is being stacked, but everything is starting from 0 to 1, again from 1 to 3, and again from 3 to 4. If you really want to make an inferences out of this particular graph, the first graph, you will not be able to make any inferences till you make your stack graph as a 100% graph. Can you see here? 100% stack. Then I can see that, okay, all are in 100%, which is good and which is bad. Is it making sense to you? If it is making sense to you, please press 3, else press 4. Awesome. Thank you, sir. Thank you, ma'am. Great going. Thanks for being so participative. Great going. Okay, perfect. So let me talk about, so these are the best practices. So a bar graph is actually represented the same as the point. So you use it because of the weight of the bar graph. So this is all about this thing. So now I have written B ways. Bars are easy to turn into ducks. Ducks is basically a concept where I say you are not able to retrieve any information out of it, and when it tell lies. Now you should know when it tell lies basically. Do you have now? If you see here, the first graph, this still lies to me. I can't make any inferences because if you see here in the March graph 0 to 1 and from 1 to 3 it is there, right? This is a wrong information. It should be 0 to 2, not 1 to 3. And you have to put a lot of stress to understand what this stack graph is or talking on about. What inferences I can make out from here, right? So these are called ducks graph. This tend to be a duck, which doesn't make any sense. Right, from if you see from left, right, everything is same. Right? So this is all about that particular objective. Let's come into the best practices. So this is a chart. So when you see here, your spacing, when you do the vertical spacing, right, the x-axis and the y-axis, you should be very prominent when you are defining this. Now, nowadays system does it for you, but even then, if you have a flexibility to mark it properly, please mark it properly. Like you see here 0, S1, S2, it doesn't make any sense. It should be a number over here so that I should be able to make inferences out of it. Okay, now if you see here, Jan Feb March, this is vertical. Just because of the spacing, we make it vertical, but it should be, the presentation should be in readable format. These are the best practices when you read, but when the data size is pretty more, we tend to do like this. Not wrong, but yeah, this practice should not be preferred. This is not a in consideration practice basically. Now when you are doing a bar graph, you see this is pretty thin and you have a very huge gap in between the two graphs. It shouldn't be. So there should be a standard spacing out of it within any graphs, right? Correct? Now if you see here, if you're putting apple, banana, orange, make it a sequential, means alphabetical wise, either ascending or descending order, right? Use consistent color. So now if it is a category, you can use different color, but if it belongs to same objective, you should be using the same consistent color until there are different categories out here. Okay, so do you have any questions right now? If you have any questions, please press 3 or press 2. Okay, you don't have any questions. Great. Awesome. Okay, great. Good going. You are in sync with me. Perfect. Now, when I talk about a standard, I have already talked about a pie chart. What is the best practices for the pie chart? Okay. Many people tend to make use of pie chart, but they don't know how to use a pie chart. Okay. So whenever you are representing a pie chart, even if it is a number, try to present it in a 100% format and try to present it in a percentage format rather than a numbers. Don't ever try to present it a number. Try to present it as a part to whole relationship. Okay. Great. So now this is the best pie chart. Now you see here, like there are so many visualization here. You are not able to make anything. So make a category out of it. Make it a small. Try to make it 5 to 6 so that it is presentable in a big way. Okay, but even if you have to show the small graph, now this is how the pie chart becomes a stack chart. This is again part to whole. Okay, because if you try to compare here, now you are not able to see the proper coloring out of it. But if you put it as a stack chart, parallelly you will be able to compare the things. But in pie chart, you will not be able to compare. Okay, this is how it is being presented. Now this is a sequential flow. Like you see 20%, 15, it is here. So you try to make it a sequential. You try to arrange it in a ranking manner so that it is being presented properly from highest to lowest. Okay, so there are best practices which people doesn't know in the market. So this should be properly when the students are doing this, they simply do it for the sake of doing it. But any industry or any organization which you go through, they observe everything and it is not for the sake of doing it, but there is an objective behind it that I should be able to make quick inferences out of it. Okay, now you can see here like order cycle. So here the order cycle is in a reverse manner. It should be either cyclic, either it should be anti-clockwise, or it should be a clockwise manner. Okay, this is how it is being presented. Line chart, you know very well, is good to present. Okay, so where you can use this if during trending, acceleration, deceleration, volatility is too much high, then all these figures where you can use this particular line chart to come out with your objective. Like in regression best fit analysis, you can do a sales versus monthly projections, or you can see value of sales. So XYZ different products are being presented out here, or a simple trending chart is there. You can use a trending chart, whether it is going up, or it is so through the trend from I can see 5.1 to 5.2 it is growing, and 5.2 to 5.3 my sales is coming down. Okay, so this is a trending chart. So how the trend is working basically. So that is where, so if you do a bar chart over here, it will not make any sense. I will not be able to find any inferences out of it if you give me a bar chart over here, because I need here the line chart, because my objective is like how my business is doing, when it is going dip and when it is going too high. So this all, once you presented this on the graph, you try bar chart, you try, and with based on the practices, once you are acclimatized with all the terms and everything, whether you want, so you have to ask the right question to your business, whether you're looking for a trend or acceleration, deceleration. So when this terms comes into picture, you quickly come to know your brain starts mapping up. Oh, I have to do a line chart over here. Oh, I have to do a bar chart. Oh, I have to do a stack chart. Right? All these things. So these are the best practices of the line chart. You can see out over here. Okay, includes zero baseline. So yeah, what I was talking about a duck is, right? Okay, now I'll give you one quick example over here. Now you take this graph basically. Okay, just now I told you it should start from 0, right? I take here 1000. I take here 2000. I take here 5000. Okay, this is one graph, and I use this graph and I plot this graph like this. Okay, I quickly plot this graph like this. Sorry. Just give me some time. Okay, I draw a graph like this. So this is giving me, sorry for the line. Basically, it will come like this. Okay. I'll just put it, this is the perfect, yeah. This is my x-axis basically, okay? One second, please. Ashish, I'm going to presentation right now. Just give me 10 minutes. I'll join the session. Yeah, sure. Okay, sure. So right now, I'm on this x-axis. Right now, you can see the graph. This is the graph. Now, if I do the same graph and I take a number over here, right? I come like this, okay, and I come like this, and my base starts with 5000. Okay. Now, when my base starts with 5000, it becomes this is how we start creating a ducks. Okay, now I put here 10,000, because what will happen is when it starts from 5,000, then your graph will it will be like this over here. Oh, sorry. It will be something like this over here, and it will be something like this over here. But if you see, if it starts from 0, basically, if this graph starts from 0, okay, the difference will be looking like there will be a small marginal difference. Okay, but if you change the